我们之前有讲过，这门课最重要是把你们的那个根基扎实一点。所以呢，我们没有特别的规划怎么样的东西是一定要教，怎么样的东西是，这基本上所有东西是可以不教的，你们都可以自己看书都可以。但是有一些有趣的东西我还是想跟你们讲，所以之后如果在学期末的时候真的是有兴趣的同学，我们还可以加开1-2班，就是讲一些有趣的东西 ，OK？ 但是现在进度 OK， 我觉得 OK， 好。Okay, so today we will talk about a new topic. So this is about counting. So some of you might have already studied this before. So counting is something that we will use every day. So in particular, we will need to know how many ways that we can do something. So let me give you some very simple example. So for instance, let us try to order a meal from Pizza Hut, okay? So Pizza Hut serves pizza and also pastas. So pastas are spaghettis, right? So let's say the pizzas, they have different kinds of flavor. They have supreme, they have takoyaki. What is takoyaki? Close. Okay, taco. What is taco? Taco. Okay, very good. Taco is taco with 8 legs. Okay. Like this? Or maybe it's not like this, I don't know. It's not like this, one of these kind of things, okay? So they have also kimchi. So kimchi is the Korean spicy veggie. And they have Hawaiian. What is Hawaiian? Pineapple with ham, okay? And then they have smoked house, I don't know what it is. They have seafood, they have veggie delight, and they have also beef. Okay, for pasta, they have a lot of flavors as well. So they have seafood marinara, so this is the red paste. Chicken curry, chicken, curry veggie, seafood carbonara, lasagna, bolognese, okay, whatever. Okay, so suppose that, so when will we need to count? So suppose that we want to order a different kind of meal every day. So each meal, you either choose a pizza or you choose a pasta. You don't choose a pizza and a pasta. So how many ways can we do so? So let me count it briefly for you. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 different tastes for pizza. And there are 1, 2, 3, 4, 5, 6. There are 6 different tastes for the pasta. So 9 flavors for pizza. So pizza, there are 9. So for pasta, there are 6. So how many ways can we choose a meal from Pizza Hut? 15. How do we know? Okay, 9 plus 6 is equal to 15. Okay, this is the so-called rule of thumb. Okay, when will we use rule of thumb? So there are some choice that we can make. If we can make this one or, so if we use or, this one, then the total number of ways is the number of ways here plus the number of ways here. Is that okay? Okay. So if we can make a choice from this group, or if we can make a choice from another group, then if you use or, then the number of ways is just the sum of them. Is that okay? Now we can have a different scenario. This time let's go to what? Let's go to McDonald's. Okay. So let's go to McDonald's. Okay, so McDonald's has what kind? So McDonald's, there is 1 plus 1 equal to 50, right? Right? So what is 1 plus 1 equal to, what is 1? And what is the other one? Anyone? This is about some meal, like a burger, like I don't know, double cheeseburger or McChicken or McNuggets or whatever, okay? And how about this one? This one could be a drink, could be, I don't know, do we have salad? Maybe salad, okay, so there are different kinds of drink. There can be salad and, I don't know, apple pie? Or is apple pie here? Where is apple pie? Apple pie is here, or you don't go to McDonald's, right? Okay, you're rich. Okay, so I go to McDonald's every day, but but then I order the same thing every time. So I don't know what we can choose from. Okay, but let's say there are different kinds of burgers that we can choose. Let's say there are 9 kinds of burgers. Is that okay? And then for this kind of drink, let's say we have Coke, we have Coke Zero, we have Sprite, we have Fanta, we have orange juice, we have coffee, we have what? We have tea. Yeah, no sugar. We have lemon tea. Okay, and then let's say we have salad. So there are also 9 kinds. Okay. Now each meal consists of one thing chosen from here and one thing chosen from here. So you may have a burger with Coke, okay, or you may have a McNuggets with Sprite, okay. So how many different combinations, how many different ways can we choose a meal? So Coke with double cheeseburger is counted as different as Coke with McNuggets, okay, because we are changing things from here. Okay, but on the other hand, double cheeseburger with Coke and double cheeseburger with Sprite, and they are also different because we are changing things from this side. Okay, so how many different ways can we choose? So there are 9 different kinds of burgers and then 9 different kinds of drinks. So how many ways are there? 81. Very good. Now, how do we get this 81? It is 9 times 9. We choose one thing here first. And then for each thing that we choose, there are the same 9 options that we are available for the drinks. Is that okay? So you have 9 things here, but then for each one, there are 9 different ways that we have. So altogether, it is 9 times 9. Is that okay? And so this one, the key here is that this is the choice that we can make. This is another choice we can make about another thing. And then we are choosing and. This is and. Is that okay? We are choosing this one and this one together. So in this case, if we are choosing and, then we are going to use multiply. And this is called the rule of product. Is that okay? So these are very simple things, but they can give us some interesting solution. Okay? Okay, so let me give you an example, okay? Okay, so let me give you an example. So it may be using rule of product, it may be using rule of sum, or it may be using both, okay? Okay, so I'm going to draw a map. Okay, so in my map, so I have a lot of cities. So these are some cities that I have. So each circle represents a city. Okay, and then between cities, there are roads. Okay, so this is city A, and this is city B. And there are roads. Roads have directions. Is that okay? So this is a directed road. This is another road. This is another road. Okay? This is a road here. 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 Is that okay? So I'm asking how many ways can we go from city A to city B? So let me show you what is the way. So I can go from A to this point, to this one, to this one. This is one way. Is that okay? Okay. And then I can also do something different, like from this one to this one to this one to this one. This is another way. Is that okay? And then from this one to this one to this one to this one, this is another way. And from this one to this one to this one to this one to this one, this is another way. Is that okay? So how many ways are there in total? How many ways are there? Okay. So this could be very complicated. Let's say if I'm drawing one more line. Okay, so this will be creating more ways that we have, right? So is there a way to do so? Okay. So to solve this problem, this is we call this a graph. Okay, so this is a graph. This is a graph. A graph contains of vertices. So these are the cities. So these are the vertices. And there are also edges. So these are the edges. And then this kind of graph, we call it a directed graph. We'll talk about this one later. This is a directed graph. And then this is a problem of counting the number of ways traveling from one place to another place. So this is actually a well-studied problem. For this simple case, we can, okay, and actually for any other more complicated case, we are using the same method. So this is the idea. So we are going to look at how many ways can we go from A to a place, okay? A to a place, okay. How many ways can we go from A to A? One, very good, so there are one way. Is that okay? Okay. If I pick out this one, okay, how many ways can I go from A to this place? One, very good, one. How do we know? This node, this vertex has only one incoming arrow. There's one incoming arrow, and it is always from A. If there is just one way from A, then there will be just one way to get to this position. Is that okay? So this is one. Is that okay? Okay. And then we are going to do this again and again. But each time, to make our decision easier, we are going to find a vertex such that all the incoming arrows, we know the number of ways to go from the arrow to that location. So for instance, I'm choosing this one to compute here. It is because for this one, there is just one incoming arrow. And for this incoming arrow, I know what is the value here. Is that okay? Now, can I do this? Now, for this vertex, if I want to process this vertex at this moment, then I will get into trouble because I know there is one way here, but I don't know how many ways are there. So let's don't do this at this moment. Okay. So among all the remaining vertices, we find that this one is good because for this one, there are two incoming edges. So coming into this vertex, and we all know the number of ways. Okay. So how many ways to get to this vertex? Two. So two. Why it is two? We are using what? Rule of sum. Very good. We are using rule of sum. To get to this location, there are two ways. One way is I get to this location and then travel this edge. Or there is another choice, or. I can do some magic way to reach this location and then travel along this edge. Is that okay? So these are two different choices. One is from this one directly with an edge here. One is I don't know how to get this one from this node or this vertex, travel along this edge. So one is traveling using this edge before coming into this vertex. The other is traveling using this edge before coming into this vertex. So I get two here. Is that okay? Now if I have two here, then the next part is I have two options. So for this one, I know every other. So for this one, there are two ways to get to this node. There is one way to get to this node, this vertex. Okay. So how many ways to get to this one? Three. Okay. Very good. To get to this one, I must be traveling using this one or using this one. Is that okay? The number of ways of using this one is one way. The number of ways of using this edge is two ways. Is that okay? So we can do this and then what? So for this one, this will be 2. Is that okay? And finally, for this one is 2 plus 2 plus 3, and it's going to be 7. Is that okay? Is that okay? Okay. So so if you know how to solve this, there is another related problem. So let's have a stair. So this is a stair. Okay. You are standing at this location. Okay. And then you want to reach how many levels? Okay. So there's 1, 2, 3, 4, 5, 6, and 7. So you want to reach to the top, okay? So each time you can move 1 step or 2 steps. Okay. So how many ways can we reach the top position? So maybe I'm reaching this like to 1, to 2, to 3, to 4, to 5, to 6, to 7. This is one way. Is that okay? Or I can do this from 1 to 2 to 3, hop and hop. So this is another way. Is that okay? Or I may be hopping, 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 and then this one. So this is another way. Is that okay? How many ways can we reach this position? Okay. How many ways? Let's try our strategy. Okay, we can make this into a graph. So this is what we call it a reduction. So a transformation. We can change this problem into a graph problem. Okay, so what are the locations? So this is 0. Is that okay? So I have a location 0. I have a location 1. I have a location 2. I have a location 3. I have a location 4. I have a location 5. I have a location 6. And then I have a location 7. Is that okay? Okay. Now, from 0, I can go to 1 in one step. Or I can directly go to 2. So this is what happens from 0. Is that okay? From 1, but I cannot go to 3 because I cannot jump 3 steps. Is that okay? So it is like I can have a direct way from 0 to 1. I have a direct way from 0 to 2. Is that okay? So from 1, I have a direct way to 2. I have a direct way to 3. Is that okay? From 2, I have a direct way to 3. I have a direct way to 4. From 3, I have a direct way to 4. I have a direct way to 5. And this one, and this one, and this one, and this one, and this one. Okay, and now you know how to solve this. You know how to solve this. Because it is the same problem as this one. It is like counting how many ways we can reach from 0 to 7. Is that okay? You know how we can solve. But let's solve it together, okay? How many ways are there? So there's one way here. Is that okay? Is that okay? And how many ways here? 1. How many ways here? 2. How many ways here? 3. Is that okay? How many ways here? 5. How many ways here? 8. How many ways here? 13. How many ways here? 21. What is this? So this is the Fibonacci sequence. Okay. So this is a method. Okay. This is a method. If you know how to solve one type of problem, let's say this is a graph problem, it may be useful to help you to solve another type problem which looks very different. Okay. And this is the technique. So we are transforming, okay, this problem into the graph problem. So we call this a problem transformation. Or there is another word computer scientists also use. We call this a reduction. Okay, so this is called a reduction. So reduction, it is like reduction. I change from one problem into another one. I reduce my problem. I change my problem to something that I know. So it looks like I reduce a problem, make it simpler to something that I have already know how to solve, and then solve it. Okay? So this is the idea. Okay? Good. And later, when you are studying algorithm later, then you can also solve this problem using another technique called dynamic programming. But basically, dynamic programming is a very special kind of graph traversal. So this is a graph problem. Okay? Okay, let me give you another one.